Hello, Accelerated Chemistry students. This is Ms. Krista Foley, and this is your Chapter 9, Section 2 video notes all over how to name and write formulas for ionic compounds. So let's talk about Lavoisier. Lavoisier was a French chemist, and he determined the composition of many compounds and found that it was becoming impossible to memorize all of the unrelated names of compounds. So he worked with other chemists to develop a systematic method for naming chemical compounds. So let's talk about writing binary ionic compounds. So a binary compound is composed of two elements. Binary compounds can be ionic compounds or molecular compounds. If you know the name of a binary ionic compound, you can then write the formula. So the first thing you're going to do when you're writing it for an ionic compound is you're going to write each ion symbol. And you're going to make sure that has a symbol, so the element symbol and the charge of the ion. The cation is going to go first, so the positive ion is going to go first, then the anion is going to go second, and that's, remember, is the negative ion. Then you're going to crisscross and reduce the charge numbers, and remember, the signs are not going to be in our formulas. And then we're going to write the charges as subscripts. And then remember, we don't write ones in chemistry. Writing the 1 in a chemical formula is the same as saying the element symbol itself. So let's look at an example. So let's write the formula for a compound containing magnesium and chlorine. So the magnesium ion from our ions that we have memorized is Mg2+, and the chlorine ion is Cl-1. So we're going to crisscross the charges, and that's going to give us a formula of MgCl2. Notice that 2 is still in blue because it came from the Mg ion, and there's no 1 because chlorine had a 1- charge. And why does this work? This works because remember in Chapter 7 when we drew the structures of ionic compounds, chlorine's going to get a electron from magnesium. And so we need to have 2 chloride ions and 1 magnesium ion to have a neutral compound, and we do. Let's write the compound containing barium and oxygen. Barium has a 2+ charge. Oxygen is 2-. We're going to crisscross our charges, and we end up with BaO. Note, since our charges of the cation and the anion are the same, we can reduce them to the lowest whole number ratio. And since they're both 2+ and 2- in this case, that is the same as saying 1 barium and 1 oxygen, which is what our formula says. Now let's talk about how we name binary ionic compounds. So if you know the formula of a binary ionic compound, you can write its name. So the first thing you need to do is you need to make sure that your compound contains a metal cation and a non-metal anion. And then you're going to name the cation first, followed by the anion. So let's look at an example. What is the name of the following ionic compound? So we have LiBr. Well, Li comes from the ion Li+. Br comes from the ion Br-. The Li+ ion is called lithium, and the Br- ion is called bromide. And remember that the cation name stays the same, and the anion is going to end in IDE. Now remember, these are for binary, so a metal and a non-metal. Let's look at another example. What if we had AlCl3? So Al is going to be 3+, Cl is going to be Cl-. So the Al3+ ion is aluminum, and the Cl- ion is chloride. So our name of this formula would be aluminum chloride. So what is the name of the following ionic compound? What about this one? CuO. Well, in this case, copper is a transition metal. So remember, transition metals could have multiple charges. So we're going to have to include Roman numerals in this case to make sure that we identify which ion we're talking about, copper 1 or copper 2. But just by looking at the formula, you might be saying, how am I going to figure this out? Well, there is an ion in this formula that we know the charge for always, and that's oxygen. It's always 2-. So if this is in a ratio of 1 to 1, because notice there's no subscripts, that means that copper also has to have a 2+ charge. So we would write copper 2 oxide is the name of that formula. These can be a little complicated, but we're going to practice in class. Now let's talk about ionic compounds with polyatomic ions. Remember, you're going to write the formulas as the same as you did for ionic compounds. You're never going to change the polyatomic ion though. And if there's more than one polyatomic ion needed, you're going to put the ion in parentheses followed by the subscript needed. Let's look at an example. A compound containing ammonium and chlorine. So ammonium is NH4 plus and chlorine is the ion Cl minus. We're going to crisscross and we end up with NH4Cl. That NH4, remember, comes from the ammonium ion, so it needs to stay there. Let's look at another example. Let's look at lithium and carbonate. So lithium is Li plus. Carbonate is off of the 60 ions that you had to memorize. So is lithium, but carbonate is CO3 2 minus. Okay, and so when we crisscross our charges, we get Li2, CO3. Now notice where that 2 came from. It's gray, so that 2 came from that carbonate ion. That's what his charge was. Let's look at another one. What about calcium and hydroxide? So calcium is 2 plus, hydroxide is OH minus, crisscross, Ca, and we have to put the OH in parentheses because we need 2 of those. We don't need 2 H's, we need 2 OH groupings. Now let's talk about when we name compounds with polyatomic ions. We're going to do the same thing that we did with ionic formulas. We're going to name the cation first, then name the anion second. So let's look at an example. We have this, NaClO. Well, Na is the ion Na plus, and then ClO is the ion ClO minus. They're in a 1-to-1 ratio. And Na is sodium, and ClO minus is hypochlorite. And so the name of this formula is sodium hypochlorite. Look at another one. We have NH42, C2O4. So our cation here is NH4 plus. Our anion is C2O4 2 minus. So I basically uncrisscrossed my charges to figure that out. The NH4 plus ion is ammonium, and the C2O4 2 minus ion is oxalate. So the name of this compound is ammonium oxalate. And let's look at this final example. Fe in parentheses ClO3 and parentheses 3. Well, who's the cation here? The cation is iron and it has a 3 plus charge. The anion is ClO3 minus. And iron is one of those, remember, it's a transition metal, so it could have multiple charges. So in this case, it's iron 3 plus, so we need to write that with a Roman numeral to know that we're talking about iron 3. And then the second part of it is the chlorate ion. So the name of this formula is iron 3 chlorate. It's not that bad. There's a lot of practice that is going to be included and involved in this, but you're going to be excellent students and practice like I know you will. And as always, all of the information on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition of the textbook resources CD and pearsonchem.com. Thank you for watching. Have a good night.